So let us do another example, example number 5. Or example 5 here. What it says is a rectangle is bounded by x-axis and a semicircle y equals to 49 minus x square. What length and width should the rectangle have so that the area is maximum? Because you can make so many rectangles under this inside that semicircle, right? You can make a rectangle like, you can make, if you want to, you can make a rectangle like this, right? Another rectangle could be like this. So you can make so many other rectangles, but what you need is, you need a rectangle with maximum area. So what should be the length and width so that the area of the rectangle is largest? That's what it is asking for. Okay, so okay, since you want to find out the dimension of the rectangle, meaning length and width of the rectangle, so what we want to do is, let us suppose that this is like, since this is the origin, right? Since this is the origin, let's suppose that this is x and this is x and then this is y. So this is basically, this point is x comma y, right? So y is that value, so you will replace y by that value. So but by the way, what is the area of the rectangle here? So the area is length times the width, right? What is the length? Length is 2x times the width is y, right? Basically this is 2xy, and you want to maximize the rectangle area here, right? So you want to maximize the area. So to maximize the area, you need to find out the first derivative of a and then set that equals to 0, all those steps we did in the previous example. But here it has x and y, so we need to replace y by that value and then find the derivative after that. Okay, so a is 2x times under the root 49 minus x squared, that is a, right? So now we need to find out the first derivative. So a prime, this is like, you can take this like f and this like g, right? So this has 49 minus x squared to the 1/2. So let me write this way. So this is like 2x, you can write just x and then 49 minus x squared to the 1/2 prime, right? This is the, we are trying to find out the derivative of that function. I'm just writing, this is like, you can say like, this is like f and this is like g, right? So what is the formula? It is like f prime times g plus f times the g prime, right? So let's do that. F prime is 2 times g is, you can write for simplicity 49 minus x squared plus f is 2x times the g prime is, it is like u to the 1/2, right? What is the formula for u to the 1/2? It is n u 49 minus x squared times to the n minus 1, that will be negative 1/2 times the u prime is negative 2x, right? The derivative of the inside will be negative 2x. Now you cancel that 2 and then that 2. What you get is basically 2 root under 49 minus x squared, right? And then minus, there is 2x and then there is x left, right? So negative 2x squared, but this has exponent negative, so I want to move this to the bottom with the root. So 49 minus x squared. So what is left? So is, I want to simplify. Before I set that equals to 0, I want to simplify this on both sides. What do I get? Is, if I simplify, I will get 2 times, this is just like, you can do cross, right? So it is root 49 minus x square, root 49 minus x square will be just 49 minus x square, and then minus 1 times 2x square will be 2x square, divide by root 49 minus x square. If you simplify this, you will get 49 times 2 is basically 98 minus 2x square minus 2x square, right? That's what you get. And then divide by root under 49 minus x square. Now let me further simplify this. You will get 98 minus 4x square divide by 49 minus x square. Now to find out the critical points, what should you do is you set that equals to 0, right? If you set that equals to 0, what do you get? You should do the top equals to 0, bottom equals to 0. If you do the top equals to 0, you'll get 98 minus 4x squared equals to 0. You will get 98 equals to 4x squared. Divide by 4, you will get and then take the square root, right? You will get 98 divided by 4 is how much? Is that 24.5 equals to x squared. So this, if you take the square root, you will get almost equals to x is approximately equals to 4.9, because 5 square is 25, right? So 4.9 square will be almost equal to 24.9. So but if you do the denominator, if you set the denominator equals to 0, what do you get? If you set the denominator equals to 0, you will get, because the critical numbers are those that makes the derivative 0 or derivative undefined, right? So find out the set the denominator equals to 0, you will get 49 minus x squared equals to 0. So 49 equals to x squared. Take the square root, you will get x equals to 7. So you will get either x equals to 4.9 or x equals to 7, right? So when x is 4.9, what will be y? Y will be 49 minus 4.9 square, right? And if x equals to 7, y will be 0. So it looks like it is not a good idea, because when x equals to 7, then you will get y equals to 0. So when y is 0, that is basically the width is 0. So the area will be 0, because length times width, right? So we ignore this value. We ignore that value. We just take 4.9. So we got x equals to 4.9 is the critical value, right? So now you plug in to find out y. So y will be under the root 49 minus x square. If you do that, you will get basically this one is also almost, let me write down here, almost equals to 4.9. That's what you get. Okay, now so we are able to find out the x and y values. So the length is what is the length, by the way? What is the length? So basically here, the width is 4.9, right? But what is the length? Length is not x, right? Length is 2x, because we said that x is half of that. So that will be 9, and then width will be, width is basically the y, right? That is 4. Oh, not 4.9. It is 4.5. 4.5. Okay. Now we want to check the second derivative for this x and y value is basically negative, because for the maximum we need the second derivative maximum. So let's find out the a double prime. If I find out the a double prime, what do I get? Is basically I need to use the quotient rule for that, right? So you get 98 minus 4x squared divided by 49 minus x squared. Okay, so you need to use the prime of that, right? You need to use the quotient rule for that. If you find out the quotient rule, and then if you use the quotient rule and find out the second derivative, how would that look like? It will be like do you know what is the formula? It is like f over z and then prime. That will give you f prime times z minus f times z prime divided by z square, right? So what is f prime? Is negative 8x times z is 49 minus x square, minus f is 98 minus 4x square times z prime. Z prime will be how did we find out the prime of what was z here? This is same the z as that z, right? What was the z prime? Z prime was negative 2x square over 49 minus x square, right? So times negative 2x square over 49 minus x square. That's what you get. Divide by g square. That is 49 minus x square only, because square of the g, right? Square of g will, the root will cancel with the square. That's what you get. If you plug in at x equals to 4.5, what do you get? A double prime. Let's check. Okay, if you plug in 4.5, positive 4.5, this will be negative, this will be positive, this is 4.9 square, this will be 0 basically when you plug in x equals to 4.5, and this will be positive, right? So basically you get negative, the value will be negative. Hence A is maximum at x equals to 4.5. So that's the solution.